Comet 3I/Atlas has rapidly become one of the most fascinating astronomical discoveries of modern times, capturing the attention of scientists, media outlets, and the general public alike. Discovered on July 1, 2025, by the Atlas Survey, it is only the third confirmed object ever observed entering our solar system from interstellar space, following the famous cases of 1I/Oumuamua in 2017 and 2I/Borisov in 2019. What immediately set 3I/Atlas apart was not just its interstellar origin, but its extreme speed, unusual composition, and a series of puzzling behaviors that have ignited intense scientific debate and, in some circles, outright speculation about its true nature. Traveling on a one-way hyperbolic trajectory at an extraordinary speed of roughly 58 kilometers per second, the object is clearly not bound to the sun's gravity and will eventually leave the solar system forever after its brief visit. Its closest approach to the sun, known as perihelion, is expected around October 29, 2025, at a distance of approximately 1. For astronomical units, placing it inside the orbit of Mars, but well away from Earth. Careful orbital calculations conducted independently by NASA and the European Space Agency confirm that the comet poses absolutely no impact threat, with its minimum distance from Earth remaining a comfortable 1.8 astronomical units, or about 270 million kilometers. From a planetary defense perspective, the object is completely benign, yet scientifically it is priceless. Astronomers quickly realized that 3I/Atlas may be the most extreme interstellar comet ever detected. Early observations suggested an object of remarkable size and activity, far exceeding expectations based on previous visitors. Data from the Hubble Space Telescope indicated a solid nucleus, potentially several kilometers wide, already large by cometary standards. However, other observations hinted at something even more astonishing. A massive object between 20 and 46 kilometers across, shrouded in a thick envelope of dust and gas. If those estimates prove accurate, 3I/Atlas would be not only the largest interstellar comet ever observed, but possibly one of the oldest, formed billions of years ago in a distant star system long before the sun was born. Even while still far from the sun, where most comets remain relatively dormant, 3I/Atlas displayed intense activity, producing a visible coma and tail that suggested vigorous outgassing. This level of activity at such distances implied an unusual composition, rich in highly volatile materials capable of sublimating under weak solar heating. As the comet approached the inner solar system, it continued to surprise observers. In late August, astronomers detected a striking and counterintuitive feature, a so-called anti-tail, a narrow jet of dust and gas pointing toward the sun rather than away from it. While anti-tails are not entirely unknown in comet science, they are rare and often fleeting, resulting from specific viewing geometries or unusual dust grain dynamics. In the case of 3I/Atlas, the feature was particularly prominent and persistent, adding to the sense that this object was behaving in ways not easily explained at first glance. This, combined with its immense speed, size, and activity, fueled a growing sense of mystery around the comet and opened the door to more speculative interpretations. No figure has been more prominent in pushing those speculative ideas into the public spotlight than Harvard astronomer Dr. Avi Loeb. Already well known for his controversial views on Oumuamua, Loeb publicly suggested that 3I/Atlas might not be a natural object at all, but instead some form of alien technology. In interviews and public statements, he went so far as to estimate a 40% chance that the object could be an artificial spacecraft rather than a comet. Loeb argued that the upcoming solar flyby represented a critical test. If the object were to change its trajectory in an unexpected or non-gravitationally explainable way after perihelion, it could imply some form of intelligent control. Such a discovery, he warned, would have profound implications not only for science, but for global society, even speculating that confirmation of alien technology could trigger widespread economic panic and a stock market crash. Comparing humanity's encounter with 3I/Atlas to a blind date with a cosmic visitor, Loeb emphasized the uncertainty surrounding the object's true nature and motivations, if any. Supporters of more exotic interpretations point to several unusual properties of 3I/Atlas as potential clues. Spectroscopic observations revealed the presence of nickel gas in its coma without the corresponding detection of iron, a combination that is extremely rare in natural environments. On Earth, nickel without iron is typically associated with industrial alloys rather than geological or cosmic processes. Additionally, the comet's volatile composition appears highly unusual. Measurements suggest that its outgassing is dominated by carbon dioxide, making up roughly 95% of the detected gas, with only about 5% water vapor. This is essentially the reverse of what astronomers expect from typical comets formed in our own solar system, which are usually rich in water ice. The object trajectory has also raised eyebrows, as it closely follows the plane of the solar system and includes a relatively close pass by Mars, about 30 million kilometers away on October 3rd. Loeb has described this alignment as finely tuned, arguing that such a path would be ideal for an artificial probe designed to survey multiple planets during a single pass. The speculation did not stop there. On popular podcasts such as the Joe Rogan Experience, Loeb entertained the idea that even if 3I/Atlas does not alter its trajectory, it could still release smaller probes as it swings around the Sun, potentially sending them toward Earth or Mars for closer inspection. These comments, combined with the timing of the comet's perihelion near Halloween, helped ignite a wave of sensational headlines and viral social media content. Dubbed the Halloween Comet, 3I/Atlas became the subject of memes, conspiracy theories, and apocalyptic rumors, with some online voices invoking alien invasions or ancient prophecies. The intense public fascination highlighted both the power and the peril of speculative science communication in the age of social media. Amid the noise, the vast majority of the scientific community has urged caution and emphasized that extraordinary claims require extraordinary evidence. Most astronomers agree that 3I/Atlas is behaving exactly as one would expect from a comet originating in a different stellar environment. According to ESA scientist Dr. Michael Kuppers, the object looks like a comet and behaves like a comet, with no credible evidence pointing to artificial origin or intelligent control. NASA and ESA have repeatedly stressed that the comet's trajectory is completely benign and poses no danger to Earth, framing the event instead as a rare and valuable opportunity to study material from beyond our solar system. Many of the object's supposed anomalies have plausible natural explanations. For instance, the sunward-pointing anti-tail can be reproduced by models of dust dynamics, in which larger grains released earlier in the comet's approach appear to point toward the Sun due to viewing geometry and radiation pressure effects. Similarly, strong carbon dioxide outgassing from the sunlit side of the nucleus can drive jets that appear counterintuitive but remain fully consistent with known physics. The comet's unusual chemical makeup may also reflect its origin in an older, carbon-rich star system, with a very different formation history from our own. In such an environment, comets could naturally be richer in carbon dioxide, carbon monoxide, and metals like nickel, while being relatively poor in water ice. If 3I/Atlas is indeed billions of years old, it may preserve a record of conditions in a long-vanished stellar nursery, offering astronomers a unique window into planetary formation processes elsewhere in the galaxy. From this perspective, the object is not an alien probe, but a natural time capsule drifting between the stars. What is beyond dispute is that 3I/Atlas has triggered one of the most ambitious observation campaigns ever directed at a comet. As it passed near Mars in early October, two ESA spacecraft already orbiting the planet, Mars Express and the ExoMars Trace Gas Orbiter, managed to image the interstellar visitor. This marked the first time in history that spacecraft around another planet have observed an interstellar object. Although the comet appeared only as a faint, fuzzied, thousands of times dimmer than typical targets, the achievement was nonetheless historic. On and around Earth, virtually every major astronomical facility has been involved, including the Hubble Space Telescope, the James Webb Space Telescope, and large ground-based observatories such as Keck, Gemini, and the Very Large Telescope. These instruments have tracked the comet's brightness, composition, and dust production, revealing that it is shedding material at rates of tens of kilograms per second.